Hi, Professor here again. I'm going to show you all about tube safety control, as requested. So thanks for the request. If there's any other stuff I can help you with, let me know. But look, so basically what I'm going to do is I'm going to talk about how tubes work and how that function of a tube, or how they work basically, relates to tube safety control, or TSC, and what these little lights are on the back, and what's basically happening. Now, what tube safety control doesn't do, right off the bat I'll tell you, it does not give you control over anything. It is an automatic process, and it does absolutely nothing in terms of you having control over whatever TSC is supposed to be doing. It is a completely passive thing. You don't have any control. But what you can do is put your pick in the back, and you can see how many times those little lights flash indicate the status of the tubes. And that's only important really when you put new tubes in. After you put new tubes in and you check tube safety control and you verify the status is okay, I'll talk about what is okay and what's not okay as well. Once you verify they're okay, that's it. Tube safety control does everything automatically. You don't ever need to worry about it, which is really the whole purpose for it. They want a worry-free, hassle-free feature on their amplifiers at Hughes Kettner, which is what it's for. And Tubemeisters are not the only tube safety control thing out there. So, what I'm going to do is tell you how tubes work, and yeah, tube safety controls or TSCs function in all of that, and how it comes into it. So straight up, these four lights are corresponding to each individual tube. Okay, so one light per tube. They do not. One light only gives information for one tube. They're not connected in any way in terms of these lights need to flash together or anything. None of that really comes into it. Different flashings mean different things. If there's like damaged tubes and stuff, but we won't worry about that for just yet. So each light corresponds to one tube. So that's what's going on. Now, how does a tube work? Well, what we have is electricity in this little graphic. I don't have computer graphics software, bear with me here. Right, so what we have is electricity coming in to a little heating element. So here's the tube's outline here. Here's the heating element. Now that heating element's coated in a white paint that emits electrons when it gets hot. And those electrons are then shunted over to this plate here. Now, if there's flowing electrons, that is literally what electricity is. So even though there's an airspace between, well, there's no air, it's a vacuum tube, but even though there's a physical gap between the two, heater and plate, electrons still pass across. And those electrons pass across, that is current. And that current gets absorbed by the plate and transmitted out to your speaker through wires and all kinds of other things. Now your guitar comes into this, and that's a full electrical signal, right? So your guitar, it creates a little electric current in a wire using coils and magnets. Those coils and magnets are called your pickups, right? So your strings attract the magnets in the pickups, and when the strings vibrate, the magnets vibrate, and when the magnets vibrate, they create an electrical signal that is the same frequency as the vibrating strings in this wire. And that wire is connected to a little grid situated directly between the heater and the plate. And because there's a little current moving around in this grid because of your guitar, the electrons is what's moving around in here. There are electrons moving around. They have a negative charge. These electrons are trying to move through the plate, and they have a negative charge. If you ever put two north poles of a magnet together, you'll know they repel each other. So the moving electrons in here mess with the electrons moving across the gap. So the electrons in here don't ever leave the grid, they're just moving around inside. And the electrons trying to move through the grid, they can feel the moving electrons in there, in the grid, and they move around accordingly. So what comes out on the other side of this little grid is the constant stream, but it's at the frequency picked up by the moving electrons in the grid. So it's kind of an indirect transmission of your guitar signal. Your guitar is not actually electrically connected here. And for physical reasons that are going on, this grid cannot act as a plate and absorb electrical current. Okay, there's some physics going as to why that doesn't occur. I won't worry about here in this little instructional thing. So that's how a tube works. Now, there's something to know about tubes. They're not a digital thing, they're very physical, they're analog. The technology's been around a long, long time. And because they're physical, the manufacturing of the glass tube can be different sizes. The plate and the heater can be different sizes apart, different spacings apart. And that means that depending on how far apart how far the electrons have to travel, that depends on how much pressure, or what is called voltage in electrical terms, which you've definitely heard of before. That's what voltage is electrical pressure. How much pressure is required to send the electrons to the plate? Well, different tubes, because there's different distances, require different voltages to send the electrons across. If you apply too much voltage, they move too fast. If you don't apply enough, they don't really make it. In both cases, you get bad sound going to your speaker. So there is a perfect harmony between how much voltage and the quality of sound needs to be applied to get the electrons across and give you a good signal at the guitar, from the guitar. Because if you think about it, if they move too quickly, they won't have enough time to interact with the electrons in the grid. So if there's too much pressure, it all happens too quick and you get a bit of a thinned out, crappy tone. If it doesn't happen fast enough, you get too much interaction and not enough hitting the plate, so you'll get like a faint, distorted signal, or what have you going on. So really that's how tubes work. Now what tube safety control does is it has a little sensor between the tube and the speaker, and it can detect the quality of the signal coming out of the tube. And so it detects the quality. It goes, okay, the signal is coming out and it's not strong enough. So it then changes the voltage applied to that individual tube until its detector picks up that the signal's correct. And so tube safety control just adjusts the input electricity by monitoring the output signal. When the output signal is fine, it stops changing the voltage and keeps it there. And it happens live, it's constantly on. So you don't really have to worry about that. It's just something that happens passively. So that's what's really going on inside the amp. Now, like I said, different tubes have different voltages required. And when they manufacture tubes, they test them and work out what the ideal voltage is and then give them a rating. And if you have a look in my other video, part 2 of how to change the tubes in the Tubemeister, you can see that there is an S1 rating on the tubes, on the power tubes that I put in. They were TAD, power tubes with S1 on the Hughes Kettner sticker. That means that 13.6 volts is required to be applied here to get the signal across there, and that's what came out of the factory. Now when I plugged the tubes in, you'll notice that there were 14 flashes or something on the tube safety control. And if we have a look down here, 14 flashes is quite a bit more. That's a rating of 6, not S1. And S1, S2, don't worry about what they actually mean. They're just reference markers for this grid here. So S, blah, blah, just doesn't matter. All that matters is what's next to it. So that 14 flashes gave 6, so 17.8 volts was required initially. And you can see that in the flashes that was going on. So if I take the tube off, the amp off standby, you can see the tubes are now all active. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8. There we go. So they flashed 8 times. So those tubes, they flashed 8 times. And that means that, because all the lights are independent of each other, that's really good that they're all working together. It's probably because I got all the tubes from Hughes and Kettner that worked so well. And that means that with 8 flashes, you can see, number of flashes, 8. Okay, so the rating looks like a 0, just one above S1 at 14.2 volts. So because they're physical systems and they get hot, they're not absolutely perfect. And you can see that here. The amp is saying that I'm getting a better tone by having 14 volts as opposed to 13.6 volts. And that small difference actually does make a difference. So tube safety control just monitors output signal, changes the input voltage until that all works. Now in terms of the safety part, because it is tube safety control, not just good tone control, even though it does work as good tone control, the safety feature is that tubes can short out. Now if the filament breaks, or if something goes wrong inside the tube, the vacuum seal is broken, or any number of things can go on, then what happens is tube safety control detects the output signal of the tube and goes, oh dear, the tube is failing, cut the tube out. and it then severs the electrical signal to that particular tube and shuts it down so that no bad signal can come out, because there's all kinds of sensitive electronics over in this section of the line in your amp, and they can be broken by a bad tube. If the tube sends the wrong electrical current out, it can fry that circuitry. So tube safety control stops that damage by turning off the tube, by having a little sensor detecting what's going on in the output signal. So we have TSC here linked up to that part. So tube safety does a sensor there, which then alters the signal for the tube. Because they're temperamental little buggers, and they do fail, and they mess up, and they're all random and so on. So this is just a good way to automatically control it. But why is tube safety control in this amp, and why is it a big deal? Well, they don't have this kind of thing in other amps so far as I know. Which means that when you get an amplifier, you need to take it to a technician to get re-tubed, because when you put tubes in with a different bias voltage is what it's called. So when you hear that word bias, you know what it means. It means the voltage that needs to be applied, or the pressure, electrical pressure or voltage needs to be applied to get a good signal across the tube. So the bias for each tube is different, or the bias voltage is different for each tube, and if you put new tubes in that have a different voltage, you need to send your amp away for 2 weeks while they bias it for you. I mean, fuck that, right? You don't want to send your shit away for 2 weeks, especially if you, like I do, and you use eternal living, so then screw that. Tube safety control does that technician's job automatically. And yeah, you don't have to worry about it. It just does it all for you. Although it is good, I mean, if you, this thing in here, really what it's for is so that I know that my tubes are S1 at 13.6 volts rated from factory. So when I go out and buy a new tube, let's say I don't have the S1 rating on here, I can use the tube safety control to work out what the voltage is, and I can then go and buy a tube corresponding to that voltage. So I can walk into a tech store and go, hey, I need a tube that has a bias of whatever voltage my same amp does. For me, it would be 13.6 volts, although if I didn't know it was an S1 rating tube, then I would say 14.2 volts, because the thing flashed 8 times. And I would indeed, if I was going to replace it, considering what I do know about the amp and what the flashes are, and even what, as opposed to the rating, there's not much of a difference here, and I would say, yes, give me the 14.2 volt tube. And that's really what it's for. It's just to help you buy the same rating tubes. Now, if you want to check the status of new tubes you've put in, you just select this little flashing TSC dealie on the back. You just put your pick in the back. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that flashed 8 times. Now what that means is that they're all matched. If they're outside tubes, they're matched, and the inside tubes are matched, okay? So if that one flashed 5 times, and that one flashed 10 times, then there's a 5 flash difference. And the manual tells me that the TSC control cannot make up the correct voltages for each of those tubes. There's too big a difference because they're hooked up to the same circuitry. So if there was only 9 flashes, so that was 9 and that was 5, there's a 4 flash difference. The manual says 4 flashes difference is okay. Tube safety control can work with that to give you the best tone. Now, it doesn't damage your amp to have huge differences in flashes, you just don't get a very good sound. And that's really all tube safety control does in terms of putting new tubes in. Again, it's about relative flashes between the tubes. So you got to pick a point of view from, say, this guy. You go, okay, how many times is he going to flash, and how many times is that guy going to flash? And if they work out to be greater than 4 flashes difference between the two, you need to go and buy the correct rating tubes. And it doesn't really matter, although some people will say, you know, different ratings will give you different kinds of sounds. If you are just concerned with the safety control working properly, then it doesn't matter what they are, as long as they all flash the same number, or close within 4 flashes of each other, which is what I mean, I guess. So that's all I can really think of for tube safety control. Rate, subscribe, like, and share. Catch you later, home slices. Peace.